அதுக்காக குழப்பம் ஆகி போச்சு. அதான் எதனா டச் பண்ணா வெளியே ஓடி போயிட்டேன் நானு. அதனாலதான் குழப்பம் ஆயிடுச்சு. ரைட்டு ரைட்டு ரைட் ரைட்.
ஸ்டார்ட் பண்ணலாமா?
Yes sir. Okay. Good morning to all. I welcome our professor and head Dr. V. Ambedkar sir, our workshop director, to the program. Good morning sir.
Good morning. Good morning.
I welcome our resource person Stephen Vincent sir from Trichy. Good morning sir.
Good morning madam.
I welcome all our organizing secretaries, Dr. K. Pravina ma'am, Dr. S. Kalaivan ma'am, Dr. V. Sushila ma'am, and Mr. Jay Prakash. I also welcome all the participants for this program. I welcome now Dr. Pravina ma'am to introduce our resource person. Ma'am, please.
Today is a new day, a new opportunity to get better, smarter, and closer to your goals and dreams. Take it.
Madam.
Happy morning to all of you.
Madam.
Gathered virtually. Today we have with us our professor and head and coordinator of this workshop, Dr. V. Ambedkar sir amidst us, and our resource person is Dr. G. Stephen Vincent from Trichy. A brief intro to sir. Professor G. Stephen Vincent is the former head Department of Statistics, St. Joseph's College, Trichy. He has more than 3 decades of teaching experience and has been serving as the head of the department for the past 25 years. He is also the former coordinator of IQAC and he is a member of the purchase committee in his college. Under his stewardship, he has organized 7 research methodology workshops. He has presented and published papers in conferences and journals. Under his able guidance, 4 candidates have been awarded PhD. His areas of specialization are research methodology and statistical tools, SPSS package, 6 Sigma quality concept, test of reasoning. He is also a 6 Sigma black belt certified person. He is a career guidance counselor and also conducting test of reasoning class for SLED and UPSC candidates. He has carried out 2 projects. On behalf of the Department of Education, Anova University, I welcome you, sir, and I welcome all the participants. Such an experienced and resourceful person is here to handle today's session on correlation and regression analysis, theory and application in research. Have a great learning experience. The platform is yours, sir.
Thank you, madam. Madam. Hello. Madam. இல்ல இங்க this meeting is being recorded என்னுடைய ஸ்கிரீன்ல மேல கவர் பண்ணிட்டு இருக்கேன். என்ன பண்றது? அது ஒண்ணும் இல்லைங்க. ரைட். ரைட். Good morning everybody. I am happy to meet you all through this conference. And the topic assigned to me is correlation and regression. I am going to divide into 4 parts. The first part I am going to give you the prerequisites, how to do tool selection, how to carry out the tool selection, etc. The second part, correlation. Third part, I am going to talk about regression analysis, including multiple regression. And the final part, I will say something on logistic regression. That is another form of regression that is called logistic regression. Therefore, now I will show, we will go for PowerPoint presentation so that you can see.
Yes, sir.
Is the PPT is clear?
No, sir. Share screen, sir.
PPT is, yes?
Share your screen, sir.
Which
Share
one?
screen.
It is not scared.
Yes, sir. Share screen. See, sir, that green color symbol in the, it's available in the menu bar. Yes.
Is it clear? Screen is clear?
Yes, sir.
Right. Now, this is the topic correlation analysis and regression analysis. In part 1, we are going to see the prerequisite. That means, suppose how to select the tool. For that, we must have a little bit, let us have a review on the research, because most of the time when you go for application and we are applying either in the classroom or in the yes, madam. முன்னாடிங்களா அப்படிங்களா மேடம் பாருங்க பின்னால தள்ளுங்களா பாருங்க மேடம் இல்ல இப்ப தெரியுங்களா பாருங்க ஹலோ யூடியூப்ல கரெக்டா இருக்குங்களா இந்த ஸ்கிரீன் போகாதுங்களா மேடம் ஏன் மேடம் ஹலோ சார் பண்ணலாங்களா எனக்கு இந்த இது மறைக்குதுங்க சார் இந்த the meeting is being live streamed ன்னு ஒரு மெசேஜ் இருக்கு அந்த மெசேஜ் வந்து மறைக்குது டோட்டலாவே எனக்கு என்னுடைய பவர் பிபிடிய இந்த ஒரு மெசேஜ்ங்க the meeting is being live streamed ன்னு போட்டு உங்களுக்கு மறைக்காது சரி அப்ப சரி ரைட் ஓகே ரைட் Right. Now, this is the overall picture of what we are going to do in this class. That is, you can see the PowerPoint presentation, correlation. Now we are going for two things: correlation and regression. And in correlation means the power to affect. You are here, both the cases, we are having two variables. Both the cases, we are having two variables, X and Y. Both the cases, we are having two variables, X. For example, here are two variables, we are having X comma Y. Whether it is correlation or regression, we are having two variables, X comma Y. Now here, what is the power of X to affect Y? That is nothing but influence. Therefore, in correlation analysis, we are studying the influence of one variable over the other. For that, we are using the term association also. And when you come for regression analysis, here you are coming for regression analysis. When you come for regression analysis, here also we are having two variables, x comma y. Here also, at least for first two variables we are having. Here also we are having two variables. But here we are studying the influence. We are studying the influence. That means the power to affect. What is the power of x to affect y? Or power of y to affect x. Therefore, this is influence. But when you come for regression analysis, the very purpose is, number one, we have to forecast. We have to forecast, predict. Therefore, whenever we go for prediction purpose, then we must get into regression. Similarly, whenever we want to study the impact, that is normally we call it as causal models. That is cause and effect models. In the cause and effect models, we are very much interested in the impact. Therefore, in such models, we are going for studying the impact. Therefore, in that case also, we must go for regression analysis. Therefore, on two occasions, it is essential to go through regression analysis. One is forecasting, prediction. For example, I'll come back. For example, what is the pattern of corona? What is the pattern of people affected by corona per day? Now, if you go for that, then you are studying the pattern. That means you have to construct a mathematical model. Therefore, whenever you want to construct a mathematical model, then you must go for regression analysis. Similarly, in the causal situations, to study the impact, you must go for regression analysis. Therefore, there is a difference. It is just we are studying the influence. The influence means either upward or downward direction. For example, suppose when x is high, what about y? Is it high or low? But here, suppose if you change x, what is the impact of x on y? Therefore, this is the first point you have to understand. Then we have to see the one by one. When we go for theory, I will give few more points. Then again, we will come here and summarize so that you can get a clear picture. Finally, again, I will come for the slide and we will get a clear picture of what we are going to do. Right. Any research, we are having 7 stages. The stage 1, normally we identify the broad area. And in the stage 2, we fix our topic. In stage 3, we are writing our objectives and hypothesis. But it is better or good practice to write down research questions first and then go for writing the objectives, because you can combine the research questions and you can form you can write down the objectives. Now, after writing the objectives or research questions, now there are situations where some questions can be answered by calculation or using some formula, etc. In such a case, we are doing some mathematical operation. But some case, your answer is yes or no, true or false, accept or reject. In such a case, you must go for hypothesis testing. Therefore, after writing research questions, from research questions, you move on to combine and write down the objectives, 4 or 5 objectives. Your research question may be 10 or 12, but combine them and write down in objective format to find, to explore, to estimate, to assess, etc. Then, among your research questions, some of the questions naturally the answer will end, not a value, not a mathematical value. Answer will be accept or reject, true or false. Therefore, in such a type of questions, then naturally you must write down the corresponding hypothesis, research hypothesis you have to write down. Then you must go for statistical testing. Therefore, the 3rd stage is very important. The 4th stage, etc., I will not bother. Therefore, for example, I'm going to give you. You can see this one. now it is a corona situation. Therefore, just I want to do a research. I want to do a research about corona. Therefore, my broad area is healthcare. I am concerning about healthcare of the people. And here, at the stage 2, I fixed my topic as a study on about corona. Therefore, when I think of corona, then a lot of questions came to my mind. First question, now what is the pattern? In what pattern the number of people affected by corona goes? Therefore, this is the question I want to know. Then the second one, if that is the pattern, then what will happen after 2 days? How many people may be affected after 2 days? That is prediction. First, I am constructing a model suitable to the given situation. Then I am going for prediction. The third one, now we are having Covaxin. Now the problem is, now I'm asking a question, does Covaxin control corona? Now this is my question, research question. Actually, does Covaxin control corona? This is my question. Then in the market, we are having at present Covaxin and Covishield. Now also I am interested to know which one is better, which one is efficient, so that I can go for that. If I find that scientifically that Covaxin is better than Covishield, then I go and take Covaxin instead of Covishield. Therefore, some of the questions came to my mind, and these questions are called research questions. Therefore, we must find out the answer for them. Now, as I told you, suppose if I go for answer, the first question is, what is the pattern? What is the pattern? Therefore, the pattern means what is the model? Whenever we think of pattern, then in research we say model. Therefore, what mathematical model is suitable to answer my question? What mathematical model is suitable for the given situation? Therefore, this is my research question. And for this research question, the tool is regression analysis. Therefore, the modeling business comes under regression analysis in statistics. The second question, if you come there, how many new cases will after? Now, from this, suppose today is July 29, what would be the number of cases on July 31st? That is, I'm prediction. Therefore, if I want to predict, then I have to make use of the model. In the model, I have to substitute, therefore, prediction. Therefore, to study the pattern or to study the prediction, then I must go for regression analysis. Then, does Covaxin control corona? Now, this is my research question. Is it really Covaxin control corona? Vaccination control corona? This is my research question. Therefore, now my, if you say internally, is there any association between Covaxin and corona, and control of corona? Therefore, now my question is reword into whether there is any association between or relation between Covaxin in controlling corona. In such a case, automatically now you are finding the influence of Covaxin on corona. That is the effort to make whether really your Covaxin make effect to change impact, in fact, make an impact effect on corona, then this suggests that I must go for correlation analysis. Correlation analysis. Now, if you come for question number 4, between Covaxin and Covishield, which one is efficient? Suppose if you go for this research question, actually you are comparing and you have to identify the best. Therefore, when comparison go, here you have to follow the hypothesis, you have to frame the hypothesis. That is what the researcher perceive is research hypothesis. Somebody may perceive that Covaxin is better than Covishield. And some other people may perceive that Covishield is better than Covaxin. And the third category people may feel that both have the same effect. Both have the same effect. Therefore, all the 3 statements forms hypothesis. I do not know which hypothesis you are going to follow. but what you perceive as a researcher is the researcher hypothesis, or normally we call it in as hypothesis in chapter 1 when we write down hypothesis in chapter 1. Therefore, don't get confusion. It must be always there is no difference. No, not like that. What the researcher perceives, then it is his research hypothesis. Remember that point. That is what I'm strongly for that. Then when you go for testing of hypothesis, their problem comes because here you are having an hypothesis which you can safely call it as research hypothesis. But when you go for testing of hypothesis, there you will have two hypotheses. One is called null and another one is called alternative hypothesis. Therefore, if you go for this, if you go for testing, you are having null hypothesis, that is H0, and also alternative hypothesis H1. Therefore, now the problem is, as a researcher's problem is, you are having your own research hypothesis. For example, you take research hypothesis. Now, whether the research hypothesis will come as null hypothesis or alternative hypothesis. Therefore, two places are there, but you have to fill appropriately. That is, some guidelines are there. We do not spend much time on that because that is not my topic. Therefore, what the point I want to tell you is, whenever you go for comparison, then you must go for via hypothesis testing. Similarly, when you go for fixing a value, can we accept that value? Answer is yes or no. Go for hypothesis. Therefore, in such cases, you must go for hypothesis testing. Right. Therefore, the first three questions is my focus point today. Therefore, we'll go into that. Now, this is a paper cutting from Hindu paper. Now you can see the number of people affected by corona, and you can see the red line. Now the pattern is given there. Now you can see that one. Now my question is, what is the mathematical formula for that? Now it follows certain pattern. And what is the mathematical formula for that? And that is called model building. That is mathematical model building. For this given situation, which mathematical formula is suitable, or which research model is suitable for this, that you have to identify. Then if the model is valid, then you can go for prediction purpose. Therefore, these things we can achieve in regression analysis, not in correlation analysis. Right. Now this is, here you can say smoking. Now the question is whether smoking cause lungs cancer. Therefore, now my question is whether smoking and cancer, lung cancer, are associated. Now this is my question. Therefore, if I want to answer that question, then I must go for correlation analysis. Therefore, whether it has effect, whether it will make an effect, then I must go for correlation analysis. Therefore, these are some of the points I want to talk with you before going for this correlation, when to go for correlation and when to go for regression analysis. Therefore, the first point you must be very clear is, whenever you think of influence or whether one variable make effect on another variable, then go for association or relation or impact, influence, go for correlation analysis. But if you go for prediction purpose, then you must go for regression analysis. Similarly, if you come for the cause and effect model, suppose, for example, you take, nowadays cell phone is very popular. Everyone is using cell phone. Now you want to study whether the usage of cell phone what is the impact of cell phone usage on academic performance of a student. Now this is a valid research question nowadays, because students are most of the time using cell phone, whether it really has an impact on their academic performance. Therefore, for that, we have to take, for example, number of hours using cell phone per day, and also Y variable as marks scored or academic achievement. Therefore, here we are having two variables. then we want to study what is the impact of the variable X on the variable Y. And whenever you come for the cause and effect situation, please remember, in that case, you cannot take the variable interchangeably. What I mean is, in correlation, it is a pair of values, X, Y. The first value, you can take it as X, and the second variable, you can take it as Y. It is allowed, interchangeably is allowed. But when you come for regression analysis, it is not allowed, because you are having two variables. Now you have to identify which variable is cause and which variable is effect. Therefore, the cause variable is always independent variable, and the effect variable is always dependent variable. Therefore, this point you must very clearly understand. Therefore, as a researcher, you have to decide. Please remember, no one will come for help. You have to decide with respect to impact study, what are the causal variables and what are the response variable or effect. Therefore, now you have to identify. Therefore, in regression analysis, you must have independent variable. Causal variables are independent variables, and they are denoted by X. If it is more than one variable, X1, X2, X3, etc. But in all these cases, we are having only one dependent variable, and therefore that is Y. Normally we take Y. Therefore, the first point you have to understand is, in correlation analysis, X and Y are interchangeable, whereas in regression analysis, it is not interchangeable. It has a specific order. All causal variables are independent variables, and all response variables are dependent variables. Now, this is just like, I hope most of the people can, some people can understand Tamil without pardon me. Now, this is just like in Tamil, we are having a saying, the same effect. Therefore, you can change the order, but the same, but when you come for other activity, just like because here we are having a specific order. After brush toothing, we have to go for dinner. Therefore, these are the things you have to understand. That is, here also two variables and here also two variables. In correlation analysis, you can interchange, but here you cannot interchange. Therefore, that is one point I want to stress. Then, these are all I have covered, right? Now, let us come for the very important part, that is tool. Therefore, for a researcher or for an applicationist, whether you are even computers application, whatever it may be, data science or MBA, whatever it may be, if you are happen to be an application side, then naturally for you, statistics is not a subject. Actually, statistics is a toolkit. Statistics is a toolkit, where in our house, we are having a toolkit. Every house we are having a toolkit. We keep it in a small box, cutting plier, hammer, screwdriver, tester, etc. So that whenever a need arises, then we select the appropriate tool. That is very important. Select the appropriate tool. Therefore, the selection of appropriate tool depends on the purpose. What is the purpose? Based on the purpose, suppose if there is a loose contact in the door or window, then you must take the screwdriver. You cannot take hammer or cutting plier. Therefore, statistics for an analyst is a toolbox, and from the toolbox, you have to select the tool appropriately, and you must know how to use it. Therefore, two things: select appropriate tool and use the tool, how to use it. These two things you must know when you go for any analysis or teaching purpose, whatever it may be. Now, what are the tools available in statistics? Several tools, basic tools are available: descriptive statistics, correlation analysis, regression analysis, testing of hypothesis, then analysis of variance techniques. Yesterday also you have seen factorial ANOVA. Therefore, so many tools are available. Therefore, for a given situation, for example, if you take the question number 1, which I showed you earlier, pattern study. Now, among this, which tool I have to select? I have to select. That you have to decide, right? Therefore, the tool selection is very important. These are all basic tools. Normally, we call it as basic tools, but these tools are called advanced tools. When you go for PhD, etc., then you must make use of multivariate tools, Margo chain, reliability models. So many models are there. And you can see the last one, regression, logistic regression also, you can see in our logistic regression, the last line, you can see the last part, logistic regression. That's also I'm going to touch on this day. Therefore, several tools are available. Now, for a practitioner, now the question is which tool to be selected and how to use that tool. These two questions you must thorough. That is the purpose of all these type of seminars. Right. Now, these are the 4 criteria. Normally, a tool will be selected. The purpose. What is your purpose? If you want to just describe, go for descriptive statistics. If you want to know whether there is any association or relationship between, go for correlation analysis. If you want to predict, go for regression analysis. If you want to test which one is best, go for testing of hypothesis. Therefore, based on the purpose, that is one criteria is based on the purpose you have to get into. Then you have to find out what are the variables involved in that particular situation. Number 3, the type of measurement scale. Please make note. Therefore, the measurement scale is very important. According to that, the tool will change. We will show in correlation analysis how the tool will change according to the type of measurement scale. And now in the category of analysis, yesterday also the resource person has talked about univariate analysis, bivariate analysis, multivariate analysis. The number of variables you are taking at a time, based on that, the tool also we have to go for tool. Therefore, these are the 4 things based on which we have to select the tool. Therefore, this point you have to make note, very, very important point. I will show you when you go for this one. Therefore, right. Now this measurement scale, just I will spend some time because some of you may have some doubt to come that. In nominal means non-measurable. Nominal. Therefore, 4 categories are there. You can see the slide. Nominal. You take simply in your notebook. Nominal means non-measurable. Also, it has categories. Therefore, it is also called categorical variable. Therefore, nominal variables are categorical variables. And then ordinal scale. Ordinal scale means very good, step. It goes step by step. Very good, very much satisfied, neither satisfied nor dissatisfied, very much. These type of formats are assigned the ranks. If you are given 4 products, ask them to give the first rank, second rank, third rank for each product. Therefore, it is ordinal scale. Therefore, it is rank order scale. And the third one is interval scale and ratio scale. And in these scales are very important, but SPSS takes both ratio scale and interval scale as simply scale. Those who are using SPSS, it will take only simply scale. Therefore, based on this, our analysis will change. I will tell you, in the course of our talk, we will see that. These are all examples. You can see the slides. After that, it is YouTube. You can see all these things. All things I want to explain, I will explain. Therefore, at this stage, the first point, if you take only one variable at a time, your data sheet has several variables. Don't forget, several variables. But the question is, how many variables you are going to select? Are you taking only one variable at a time? Your data may have several. For example, if you are taking semester, you are having 5 subject mark. Are you taking only one subject, and for that subject you find mean, median, etc.? Then it is called univariate analysis. If you take 2 variables at a time, therefore, at a time, how many variables you are going to deal? Your data file may have several, good number of variables. It is immaterial. But for an analysis, how many variables are you going to consider? If you consider only one variable, it's called univariate data analysis. If you consider 2 variables simultaneously, it is called bivariate data analysis. If you go for more than 2 variables at a time, then it is called multivariate data analysis. Therefore, these are all prerequisite, and we will pass on to the part 2. we'll pass on to the part 2. Right. Now in the part 2, now we not bother about much slide because concept is very important. In the part 2, in the descriptive statistics, we are considering only one variable at a time, the mean, median, etc. But when we have two variables, then naturally the question arises whether the two variables have any relationship. Therefore, this is the question: relationship / association or has influence. Therefore, these are all terminologies used in correlation analysis. Therefore, two people are there, X and Y. Suppose if two people are there, you can describe the first person, that is X. Also, you can describe the second person. Besides that, normally, suppose two students, student A, student B. Then you can describe about the student A, and also you can describe about student B. Then it is called descriptive statistics. But if you go for, is there any relationship between them? Two people are there. Now you are going for any relationship or any association, or is there any impact, that is any effect thing, then you must go for correlation analysis. Therefore, the purpose of correlation analysis is, or when to use correlation analysis, whenever you want to study the influence or association or relationship. These are the terminologies used interchangeably with respect to correlation analysis. Right. The correlation analysis tells us whether there exists any relationship. First point, whether there exists any relationship. Answer is, it may be yes or no. Particularly, please make note as a researcher or a teacher. Actually, we are concerned about linear relationship. Don't simply write relationship, linear relationship. Therefore, our question is, between these two variables, whether there is any way, any linear relationship. First of all, we have to answer the question. Therefore, three questions we have to answer in correlation analysis. Is there any linear relationship? The second question, you have to answer what type of relationship. And the third type, you have to see what is the strength or intensity of relationship. Therefore, these three things you have to answer in correlation analysis. Right. Now, before going for that, when you talk about relationship, you must know what are the relationships available. What are the relationships available? And there are 5 relationships available, linear relationships available. One is positive correlation, then negative correlation, positive perfect correlation, negative perfect correlation, and uncorrelated. Now here you must very careful. Please make note in your notebook if you're scribbling pad. Here you must, suppose if you come across, we will find out how to find out whether positive correlation or negative correlation, etc. All these things will come later. Now, what other types of relationship means? Suppose even if you take uncle, then there is a definition for that. Then there is a definition for that. Similarly, here also positive correlation, negative correlation, that is direct relationship, inverse relationship, perfect direct relationship, perfect inverse relationship, and uncorrelated. Now, the very important point is uncorrelated means linear correlation is absent. Therefore, don't say they have no relationship. Only we can interpret linear correlation is absent, whereas there may be non-linear correlation. I will show you a slide. I will show you a slide. Non-linear correlation may be present. Therefore, don't say no relationship. Simply say linear correlation. Linear relationship is absent. That's what you can say. Right. Now, we are having 5 types of relationship. And how we are dividing this 5 type, how to identify this type of relationship. And for that, we are having 3 methods. These are all description about positive, negative. Already, either one way or other, you might have come across in your UG or PG statistics. Therefore, the basic statistics, I need not spend much time. I am very particular about the concept. Right. Then, when you go for the study, you are having graphical method, scatter diagram method. Through scatter diagram method, you can draw plot the points, and from the pattern of the points you can say whether it is positively correlated or negatively correlated, or positive perfect, negative perfect, or uncorrelated. These are all textbook is available, but the problem is it will tell you positive correlation, negative correlation, or whatever it may be, you can roughly identify, but it will not give the intensity. It will not give the intensity. And therefore, in order to give a clear picture, we must go for a mathematical formula, not graphical procedure. Graphical procedure is helpful. I don't deny that, but we must go for mathematical formula. For that, we are having two formula. One is given by Carl Pearson product moment correlation. Therefore, here you can go for Carl Pearson product correlation movement. Therefore, here your variable is x, two variables x and y. Now your x is quantitative, that is measurable. If your x is quantitative and your y is also quantitative, then you have to make use of Carl Pearson's coefficient of correlation. That is a formula, even SPSS, that will give you correlation R. Therefore, from this we are finding the value R, and this R, I write here, this R is greater than or equal to -1 and less than or equal to +1. When it is, suppose if you draw a graph paper, then this is 0, this is 0, and this is -1, and this is +1. This is +1. Therefore, this area, normally this area, we call it as positive correlation, and this area, we call it as a negative correlation. We call it as negative correlation. Therefore, we find R and see the sign. If the sign is positive, then you say positive correlation. And if the sign is negative, then you can say negative correlation. And if R is approximately, if your R, sorry. And if your R is
Sir, your voice is very.
hello? How to change the screen?
Sir,
இந்த ஸ்கிரீன்ல வேற என்ன நிறைய வந்துருச்சுங்களே.
escape கொடுங்க சார், escape கொடுத்து மறுபடியும் வாங்க.
எஸ்கேப்ங்களா? எஸ்கேப் வரலையே.
இல்ல அப்படிலாம் ஸ்டாப் ஷேரிங் கொடுத்துட்டு மறுபடியும் ஷேர் பண்ணுங்க.
ஜேபி சார் சொல்றது மலர் விழின்னு ஹேஷ் ரைன்ஸ் பண்ணிருக்காங்கல, அது சொல்றாங்க எடுக்க சொல்லுங்க.
இல்ல இல்லங்க வேற கிரீன் கலர்ல இருக்கு பாருங்க சார், ஷேர் ஸ்கிரீன்
இருக்கு. இந்த ஃபைல் போயிடுச்சு, ஃபைல் பிபிடி ஃபைல்
இல்ல என்டையர் ஸ்கிரீன் கொடுத்துட்டு நீங்க நார்மலா டெஸ்க்டாப்ல இருக்க எங்க வச்சிருக்கீங்களோ அப்படியே ஓபன் பண்ணி எடுத்துக்கலாம். ஷேர் ஸ்கிரீன்ல என்டையர் ஸ்கிரீன் ஒரு ஆப்ஷன் இருக்கு பாருங்க.
ஷேர் ஸ்கிரீன்
கிளிக் பண்ணீங்கன்னா என்டையர் ஸ்கிரீன் ஒரு ஆப்ஷன் இருக்கு.
Is it visible now?
Okay, sir.
Right. Right. Therefore, now the correlation coefficient now this is the formula, and here you can see our correlation coefficient lies between -1 and +1. This you can see. Right. Now, in the real life situation, suppose if we introduce our your relative. Suppose if we introduce our relative, suppose if other person is here, we want to introduce. If he is not our relative, then we will say he is our friend. That is uncorrelated. But if he is our relative, then instead of simply saying relative, then we are using the word he is our distant relative. See, when you use introduce, say he is so and so, he is my distant relative. Sometimes you are saying that he is my close relative. And sometimes we are using the word, in Tamil culture, we are using the word Pangali. That means blood relationship. Therefore, instead of simply saying relationship, you must also say that intensity of relationship. He is a related, but the question is whether he is distant related or close related or blood related. Therefore, in correlation analysis, after finding the formula, then you must make use of the intensity of relationship. And from Pearson's correlation coefficient, if your R is around 0, close to 0, then you conclude that it is uncorrelated. For that, roughly I have given the table. I myself have given this form, this table. This will tell you, instead of simply saying that uncorrelated, that is positively correlated, you say highly positively correlated, moderately correlated, etc. Therefore, whenever you give interpretation, whether it is positive side or negative side, whenever you are given interpretation, you also give the intensity of relationship. Therefore, your correlation analysis will tell 3 answers. If R is equal to 0, close to 0, for example, R is equal close to 0, then uncorrelated. Therefore, nothing to say further. Stop with that. But if it is correlated, then second question, whether it is direct relationship, that is positively correlated or negatively correlated. The second question. The third question, even if they are positively correlated, then what is the intensity? Is it a close relative, that is moderately correlated, or highly correlated, or very highly correlated? Therefore, all these terminologies you must make use of. Similarly, in negative sense also, so I will say in Tamil, so that, sorry for others, Nama Tamil negative, for example, he is my Pagavan, then Virodhi, then Janma Virodhi, then Parama Virodhi. So therefore, even that you are giving the strength of relationship, strength of intensity. Therefore, the same pattern you have to follow while you go for correlation analysis. Right. Therefore, these questions you can answer through Pearson's correlation coefficient if your X is happen to be quantitative and Y is also happen to be quantitative. Right. Then suppose if X is categorical. Now here you can see one demo, and here your correlation is, you see how to interpret. Suppose one problem, the correlation is given as R is equal to 0.3. Therefore, it is height of the father and height of the son. Therefore, the sign is positive. Therefore, there exists a positive correlation. Is there any relationship? Yes. What type of relationship? Positive correlation. What is the intensity? Actually, it is more than 0.5. Therefore, I can say highly positively correlated. Therefore, these 3 ways you have to interpret. Then, if you are happen to be, your X is ordinal and Y is also ordinal, then in that case, you must go for Spearman's rank correlation coefficient. Spearman rank. The Spearman rank correlation coefficient, instead of association, please remember, instead of association, we are more concerned about agreement. Because in a competition, beauty contest, competition or oral some competition, you can see 2 judges or 3 judges will be there. They will give the rank for the people. Therefore, you can see 3 judges assessing a competitor, assessing competitors. Now the question is whether they agreed. What is the level of agreement? What is the level of agreement? Then for such cases, your data is ordinal data and X is also ordinal, Y is also ordinal. In such a case, normally we go for research question as what is the level of agreement between them or among them, between them or among them. Therefore, this type of things we are concerned, but the interpretation is almost similar. For that, you can make use of these guidelines. The third one, see, for example, you can see the illustrative example, one example. The answer comes to be, for example, the same answer, but here we are using row. Please remember, we are using a Greek letter rho for rank correlation coefficient, and therefore here it is agreement. Therefore, there is a high agreement between referee A and referee B. That is our answer. Therefore, positive sign means agreement. If you have negative sign, it is disagreement. Then what is the intensity? That also you have to incorporate while you go for your interpretation. While you go for interpretation. Then next we will go for attributes. Now you know what is attribute. Attribute means not measurable. Not measurable. Therefore, not measurable, just like sex. It is not measurable. Only it is category, male or female. Then performance, good, average, poor. Therefore, all these things are all attributes. Now, the question is, are pure or not pure? Therefore, these are all attributes. That is non-measurable. Non-measurable. Therefore, if you want to find out whether there exists any association between two non-measurable, or if you want to find out whether your X, here also you are having X and here also you are having Y, and it is qualitative. It is qualitative and your Y also qualitative. Y also qualitative. Therefore, this implies that this data is categorical. This data is categorical. Therefore, all data have the categorical structure. And therefore, this is also categorical. When you say categorical, please remember, ratio and ordinal will not come under categorical. Will not come under categorical, where nominal and ordinal will come under categorical. Therefore, you want to find out the association, but the nature of X is, the measurement of X is qualitative, that's categorical, and Y is also categorical. Then you cannot make use of either Pearson's correlation coefficient, or you should not make use of Pearson's correlation coefficient or Spearman's rank correlation coefficient. Here you must go for chi-square test for independence of attributes. Please remember, chi-square has several tests. Goodness of it, chi-square test for variance, etc. Therefore, the title of this test is chi-square test. Okay, in the chi-square test, you are testing for independence of attributes. See the word. Because of the word independence, whenever you write down your null hypothesis in testing procedure, you must say attribute A and B are independent. Don't write there is no significant difference between A and B. It is wrong. When you make use of chi-square test for independence of attribute, because independence, see the word independence, therefore you must say the attribute, because we are talking about attributes, therefore attributes A and attribute B are independent. That must be your null hypothesis, H0. The H1, they are related. They are related. Therefore, that point you have to remember. And for example, we'll go for, already you might have seen, we must go for a test. You have to calculate all these things and we must go for a test. This is an example. And the test, according to this, your p-value is 0.035 and therefore the null hypothesis is rejected. We reject H0. We reject H0 and therefore and conclude H1 and accept H1. Our H0 is the two quantities are independent Now we have to conclude that they are related. They are related. That means they have the effect. One has the effect over the other. Therefore, this way you have to make use of. Right. For example, you can think of this. This is a question. Suppose I ask you to whether Covaxin is effective or not. Covaxin is effective or not. And for that, I have given some data. And for example, suppose if your P is 0.02 and if your alpha is 0. This is an exercise. You please try. You please try. I will give you 2 minutes time. Now you take Covaxin. Covaxin is inoculated, not inoculated, affected, not affected. Now, one is inoculation is an attribute, yes or no. Another one is whether it is affected, yes or no. Therefore, 2 attributes. I want to find out whether inoculation has any effect on the Covaxin affected, Covaxin, and I have collected some data, and my answer comes P is 0.02. Therefore, when P is 0.02, come here. What is our interpretation? Therefore, it is 0.02. Our H0 is rejected. H0 is rejected. That means when H0 is rejected, H1 is automatically accepted. Now, what is our H1 in this case? The inoculation is effective. H0 is inoculation is not effective. Therefore, if this is your result, then the conclusion is inoculation or vaccination is effective in controlling COVID. Effective in controlling COVID. Suppose if this is your answer, then your H0 is accepted. Then your H0 is accepted. That means H0 is true. Now, what is your H0? Go for H0. Your H0 is Covaxin is not effective. Independent means no relationship, effect, not effective. And therefore, here this concludes that Covaxin is not effective in controlling the corona. Therefore, this way you have to interpret. Therefore, the very important point as a researcher, as a teacher, is careful about our null hypothesis. The null hypothesis, they are independent. The word independent comes, suppose Covaxin and vaccination. Vaccination and disease. These 2 are independent, means the drug, the vaccination has no effect. Vaccination has no effect. That is the internal meaning. Therefore, when you go for research, you have to give not independent. Instead of that, Covaxin is not effective in controlling the corona. Alternative hypothesis, Covaxin is effective because it is opposite. Complement we have to write down is effective in controlling effect. Then do the practical, do the experiment, and see what is your P value and what is your alpha. And based on that, which one is to be accepted, either first H0 or H1. Then you come to the conclusion. Therefore, these are the things with respect to correlation. Now we are going to wind up this session, wind up this part, not session. And therefore, now here we are going, you can see, now this is what you have to remember. As I told you, based on purpose, you must get into the area. Therefore, as a researcher, if you want to find out any association, relationship, or influence, then you must get into correlation. But when you get into correlation, you are having 3 tools: Pearson's coefficient of correlation, Spearman-Rank correlation, then chi-square test. Then which one to be selected appropriately, you have to select. And for that, the guidelines is if X is quantitative and Y is quantitative, go for Pearson coefficient and do the interpretation based on R. If X is rank order and Y is also rank order, that is ordinal, then go for Spearman's rank correlation coefficient, rho, and based on that, you interpret your result. That is, answer those 3 questions. At least 2 questions: what type of relationship, what is the intensity. Then, if both are categorical variables, then in that case, go for chi-square test for independence and tell the world or tell other people whether they are related or not. Therefore, to know whether there is any association or relationship or influence, we must go for the correlation analysis, right? Now we will pass on to part 3, the regression analysis. We are going here, and as I here you have to remember before going into the slide, but here you have to remember whenever you go for the modeling is no problem. Modeling, you are having X data, Y data. For example, number of days, X, Y. If you go for pattern, then it is just reading from that you can make use of. But if you go for causal models, that is if you want to study the impact of IV on DV, then you always try to, if it is your research study, first and foremost, you draw the causal diagram. You draw the causal diagram. That is causal, cause and effect diagram. Cause and effect diagram. Right. Now, how to draw? Therefore, as I told you, the cause must be an independent variable. Therefore, for example, if you take cell phone usage, cell phone usage and academic achievement, and academic achievement, then you have to draw the figure like this. This is called cause and effect diagram. Therefore, X, and this is cell phone. And here you have to your response variable or depend. This is IV, independent variable, and this is your dependent variable. And dependent variable is always we are using the letter Y. Then to mark impact, I am drawing an arrow. Now this is impact. In Tamil, தாக்கம். அவருடைய தாக்கம் என்ன அப்படின்னு பார்க்கிறோம். Then this impact quantity, we are using the letter beta. We are using the letter beta. Now, this is academic performance. Why is student academic performance? If it is affected only by cell phone, then this equation, that is the equation Y. Equation is Y is equal to, that is variable equal to this beta times of X. Beta times of X. Please remember, as a scholar, you must ascertain. Suppose for the academic performance, only cell phone is the only factor that will affect. Then this is the equation. But we do not know. Some other factor also affect some other reasons or friends or etc. Therefore, what I am doing is other effects that I will denote it by here, and I will use alpha and alpha. Therefore, the equation I have to write down is Y is equal to alpha plus beta of X. And this is because of cell phone. His academic performance depends on because of cell phone usage and also some other factors which we have not mentioned. Please remember, it's not error. Normally, some people will use the term error. Therefore, not error. Therefore, this is some other factor which is contributing. Therefore, this we write down an equation. Therefore, regression analysis, what we do is we are going to write down a causal picture, and based on causal diagram, we are writing an equation. And equation is a model. Equation is called model, mathematical equation. Now the question is whether to study the impact of cell phone on academic achievement, whether this is my suggested equation. See, your Y is equal to alpha plus beta X. This is suggested equation. Please remember, until it is accepted, it cannot be the model. It is a suggested equation. Now my question is whether this model suitably describe the situation. Yes, that's what I have studied. The answer I have to give is, if it is really affect, number one, yes. If so, what extent? That is the impact. Beta will tell you that. Therefore, when you go for any causal analysis as a researcher, as a teacher, then first of all, you draw cause and effect diagram. Maybe with one variable or with more than one variable, draw the diagram, and from that you form an equation, mathematical equation, as I told you, or even for 1 minute, I'll come. Now I will make use of this space. Suppose if I want to have, please, I am giving you an exercise. Please do the exercise now. Now this is x1. Please do the exercise now. Wherever you are, don't worry. Therefore, now 3 variables. For example, if you take this as yield, suppose if you take y as yield, then this is rainfall, then fertilizer used, amount of fertilizer used, then soil fertility. Therefore, yield is affected by rainfall. Yield is also affected by fertility, fertilizer used, quantity of fertilizer used, and yield is also affected by soil fertility and irrigation, etc. Therefore, since it has impact, I am drawing the diagram. Similarly, this has also impact, and this has also impact. Now, this is what I call it as cause and effect diagram. Right. Now, based on that, now you have to construct an equation. Please construct equation. Now, the impact of this one is beta 1. The impact of this one is beta 2. And the impact of this one is beta 3. And beside that, see, I have not included the irrigation facility or seeds, quality of seeds, etc. Therefore, what I am doing is all other things. Contribution of all other things is alpha. Now, what is the model? Please write down, kindly write down, then only you can easily follow me what I am saying. Therefore, the model is, you please simply multiply beta 1 into x1. First write down alpha, then beta 1 into x1 plus, when you come here, it is beta 2 into x2. When you, with respect to soil fertility, it is beta 3 into x3. Now this is a model, but this model is linear model. Now some people may have some confusion, therefore I am explaining this term also. Please remember, now here we are introducing a concept called parameters. When you study the books, they will tell you parameters. Now what is that? Parameters are unknown quantities in the equations. Unknown quantities in the equation. Now, do you know why? Yes, because y is a reading from data. Then do you know x1? Yes, it is what is the rainfall? It is given. And x2, it is given because you know how much fertilizer you have used. And the x3, it is also given. Therefore, in the equation, the unknowns are beta 1, alpha, then beta 2, and beta 3. Therefore, these unknown quantities are called parameters of the equation. And in constructing the model, the parameters of the equation must be estimated. Please remember, from that available data, you have to estimate the parameters. After that, we have to write down the equation. We will see when we come there. You have to write down the equation. Then only it becomes a model, right? Now, they are very often using a word called linear. Please make note. Therefore, now my question is, now I have given a model. Now, whether this model is linear or non-linear. That is the question. As a scholar, you have to answer. whether the model is linear or non-linear. For that, what you have to do is, you have to look at the power of the parameters. You see the power of the parameters 1, and beta is a parameter, power is 1. 1, 1. Therefore, if the power is 1, all the powers of the parameters 1, then you have to say it is linear. It is linear. Therefore, linear means the power of all the parameters are 1. Therefore, this model is called linear multiple regression model. Of course, we are having more than one independent variable, therefore it is multiple. Therefore, linear multiple regression. Linear multiple regression or linear multiple model. Right. Suppose on the other hand, please make note. I think the space is the problem. I will write, don't mistake me. I will write here. Suppose in the same equation, suppose if alpha plus beta 1 into x1 plus beta 2 into x2 square. Another equation is y is equal to alpha 1 plus beta 1 square x1 plus beta 2 x2. Please look at the equation. Now, you tell me whether the equations are, which one is linear, which one is non-linear. That you have to tell me. How to identify? Please go for the power of the parameter. The power is 1. So in mathematics, if the power is not mentioned, it is 1. If the power is 2 or 3, that will be mentioned there. Therefore, the power is 1. Here also parameter power is 1. Here also parameter power is 1. Therefore, it is a multiple, more than one independent variable. Therefore, it is a multiple linear model. Suppose if you come here, please see the power is 1, but here the power is 2. Since look at the power, not 1, it is 2. Therefore, it is a non-linear. Non-linear. Therefore, this point you have to remember. Most of the times we are going for multiple linear model, but also remember there are certain situations where the non-linear models are more suitable than the linear model. Therefore, that point also you must aware. You must aware, right? Therefore, these are the first few points I want to tell you. Therefore, you must know the difference between independent variable and dependent variable. All cause variables are called independent variables, and the response variables are called dependent variable. Independent variables are always denoted by capital X, and the response variables are denoted by capital X or small x, and the response variables are denoted by Y. Denoted by Y. First point. The second Y, regression analysis. Actually, we are constructing, finding the relationship between independent variable, mathematical relationship between and dependent variable. Right. The mathematical relationship may be many, but when you write down, you have to look at the power. If the power is 1, then it is called linear. Use the word linear model. And if the power is 1, you have to write down the non-linear model. Similarly, look at the number of variables, independent variables. If you have only one variable, one independent variable, then you must make use of the word simple. Please you. Therefore, linear model is there. Linear, I have to write. Suppose linear model is there. Now the question is, sometimes we are having simple and multiple. Therefore, from the parameter, you identify whether all the power of the parameters are 1, then you say linear model, right? Now go for the right side. If you have only one independent variable, that is here, it is 1. Here your IV is 1, but here your IV is greater than 2, sorry, greater than 1, and take greater than 1, maybe 2 or 3, then you have to say multiple linear model, Therefore, regression analysis, that is very important point. Therefore, we are finding the parameters values using SPSS or some other software, and then we are constructing the equation. Therefore, now we'll go for the equation. I've skipped so many slides. When time, you can go through. Therefore, this is the thing I want to state. Therefore, in your equation, you are having betas, and in your equation, you are having the purpose of beta is the strength of impact. What is the impact? Impact you are studying. Therefore, the impact will be known from the beta value. Impact known from the beta value. These are all theory. Therefore, don't worry about the theory, because I know you are all familiar. In one way or other, you have studied in your academic program. Right. Now you come here, how to interpret? That is the question mark now. How to interpret? Therefore, now look at the equation. Of course, in my screen, a lot of messages are there. Therefore, I could not locate the ideal location anyhow. For this, your y is equal to, see, in mathematics, now we have to know some mathematics. Y is equal to mx plus c. Now this is the equation of a straight line, and when we come for statistics, and this will become alpha and this will become beta. That's all. Therefore, now when you come for regression analysis, then we are using alpha plus beta x, and alpha is the intercept. Therefore, according to the, see the title, intercept is 2. Intercept is 2 plus, then beta slope is 3. Therefore, 3x. Now this is the equation for this line. Right. Now how to interpret? Now this is your IV. This is your IV, and this is your DV. Now how your IV impact Y? Now this is the question you have to answer. Right. For that, now this is your beta. You see, in the place of beta you are having, beta is the impact. Beta is the impact. Therefore, here it is given as 3. It is given as 3. That means if you increase x, by 1 unit, please remember, not 1-fold, 1 unit, then your y, it means your y will be increased by 3 unit. Because this 3, that is the meaning. 3 unit. Therefore, that is the meaning. Therefore, for example, if it is sales, suppose if you take this as quantity of sales, and this is advertisement, amount spent on advertisement. If you spend 1 unit on advertisement, then your quantity will increase by 3, not 3 times, increase by 3. Now come for illustration, come for this figure. Now when it is 1, x is equal to 1. Now look at the value, it is 5. Now from 1, I am going to 2. That means I am increased by 1 unit. My x is increased by 1 unit. Now see what is the value of y. Now you can see y is 8. That means originally it is 5. Now it is increased to 8. Therefore, there is an increase of 3. And this 3 is nothing but your beta. Suppose if it is advertisement sales, suppose if this is 1 rupee, suppose if it is 1 or 0.1. Suppose your beta is 0.1. Look at the same equation. If it is suppose the same equation, suppose y is equal to 2 plus 3x, it's not 3x, y is equal to 2 plus 0.3x. And then what is the interpretation? Suppose if it is advertisement, and this is a quantity of sales, this is sales. That means that if you increase your x by, if your x by 1 unit, then the increase in y will be only 0.3. That means you have to advise the company, don't go for advertisement, because it will not give the desired result. That means sale of quantity will not increase. Therefore, don't do advertisement. Therefore, this will tell you, this way you have to interpret. If it is 3 times, if it is 3, then you can say you invest so that the quantity of sales will increase. But here, it is not significant increase. Therefore, you can advise the company, don't spend your money on advertisement. Therefore, this is impact. Therefore, your regression analysis will give you the impact, whereas your correlation will give you the influence. Therefore, this is the way you have to interpret. Therefore, beta is, the interpretation of beta is for every unit increase in a particular variable, an independent variable, what is the corresponding effect on y? That is given by beta based on data. Therefore, if when you come for multiple regression analysis, now these are all over, I will come for. Now this is non-linear. Therefore, your regression may be non-linear also. For example, second degree parabola is there, exponential curve is there. For example, the answer for the first question, have you seen the first question? That is, what is the pattern of corona? What is the pattern of corona? And you can say that is nothing but exponential distribution, follows exponential pattern, and therefore it is non-linear pattern. Our corona, increase of corona, growth rate of corona follows the non-linear pattern of exponential distribution, not linear pattern. That is, if you construct linear model, then it will be rejected by chi-square. Now, these are all some of the non-linear models. And in this model, and one curve, you have to be very interesting. I don't know where is it. Now, this is your corona follows this pattern, you know. Your corona, just like this pattern, your corona follows this exponential pattern or power function. This follows exponential factor. Now, we are going for multiple regression analysis. As I given earlier, you have a lot of things. Yearly income, then educational level, age, etc. They are given you. Right. Now, the first one is your income. You are given an age. Therefore, that is you are given. And thus here you are going for prediction. Therefore, the first one, your education. What is the contribution of education towards income? Now come for interpretation. This is your income. Y is your income, yearly income. And this is contribution of education. And this is age, contribution of age. Now, which beta is greater? This is greater. Therefore, this education is contributing more towards income than age. Age also contributing positively, and education qualification also contribute positively. But education contributes more. That is, impact of education is more on Y than age. Of course, age is contributing. Therefore, this is the equation. And this equation, if you substitute the education level as 10 and age as 5, then what is the corresponding value? That is prediction purpose. You can make use of it. Therefore, two purpose is for regression. One is finding the impact, which one impacts. The second use is how much, that is what would be the predicted value. Therefore, on two counts, we are going for regression analysis pattern and also the causal models. Causal models we are going for. But remember, whenever you go for modeling, the very important point is model. Whenever you suggest a model, then very important point is validity. Very important point is validity of the model. Therefore, this must be established. Please remember, as a scholar, don't simply suggest a model and proceed. You cannot proceed like that. You must show that this model is valid for the given data. Then only your research is complete. Also, you can go for the prediction purpose. Therefore, model validity is very important. And when you go for regression analysis, for the multiple regression analysis, one is R square. One is R square value. This R square must be close to 1 will be better, R square value, the output. Then when you go for, you are taking an assumption that independent variables are not contributing towards dependent variable. Therefore, those who are using, already used the multiple regression analysis in SPSS, you will have the first table, and that table will give you R square. In the table you can read your R square, and if your R square is greater than at least 0.5 or 0.6, it is good. It is acceptable, but if it is 0.8 or 0.9, it is super. Therefore, the models, these are all measures to find out the validity. The second one is the SPSS will give you an Anova table. Will give you an Anova table, and in the Anova table, our H0 is IV has no, that is independent. IV has no influence over DV. Therefore, this is our H0, and if you want to proceed further, this must be rejected. This must be rejected. Therefore, in the Anova table, it must be significant. In the Anova table, you must get the result significant. Therefore, if these two things are okay, then you can go for equation. But before that, there are so many assumptions with respect to multiple regression analysis. All those assumptions, this R square value is there, and I have given it. Please go through, and you will get some idea, right? But this multiple regression analysis, we are involving several variables, and therefore, and several problems comes, and all those problems must be solved. Number one is linearity. That means whether all the variables are linear, that you have to find out. Then the variances of each variables are almost equal. That is called homoscedasticity, that you have to ascertain. Then autocorrelation, whether one data affect the other. That is called autocorrelation is present, or multicollinearity. That means each variable must be independent. The variable should not be correlated in the multiple regression analysis. Therefore, multicollinearity, that you must include all the required variables. If you don't include, it is equation error, specification error. Therefore, these problems will come in multiple regression analysis, and this multiple regression analysis, we have to be very careful. First of all, we have to verify the assumptions, and we can make the changes, and from that we must go for the multiple. The assumptions must be verified, and if there is any mistakes, we have to correct it. And after that correction, you can go for multiple regression analysis. If the model is fit, you can go for analysis. Sorry for a minute. sorry, it is an external disturbance, unavoidable disturbance. Right. Therefore, when you go for multiple regression analysis, the point I want to make you to understand is there are several assumptions. All those assumptions you have to check whether they are met. Beside that, then you must go for model validity. And if the model is valid, then your research is okay, fine. Nobody will question on earth. Then you can interpret, etc. Therefore, these are all with respect to multiple regression analysis. Next, finally, though first, this is not in the part of talk, but Madam told me to say something on this logistic regression analysis, because this also ends with the word regression analysis, and hence I also want to say something on that logistic regression analysis. Right. Now, this is, first of all, this is a lot. What is the difference between multiple linear regression or logistic regression analysis? Now the same, you can see the equation, same type. You can see the equation, what you are having in multiple regression analysis. The same thing you can find here also. Almost certain structures are same, but only the interpretation things are different. Right. Here, you must understand that in multiple regression, your DV is a continuous variable. That means measurable variable. Therefore, if you want to make use of multiple regression analysis, then your dependent variable must be a quantitative variable. Then only we go. But suppose if your dependent DV is happen to be a categorical variable. Now it is a categorical variable. It's a categorical variable. Therefore, we are having two categories. But in the coding, what we do is we are giving any number, but normally we give number 0, 1. Therefore, as a code, we are giving 0, 1, 0, 1. Right. Therefore, here the same thing, but first difference is the left-hand side. The left-hand side, that is dependent variable, is a dichotomy. It's a dichotomy. That point you have to remember. For example, when you study the characteristics, he may have helpful attitude or unhelpful attitude, dichotomy. Then, suppose if you do some procedures or some effort, it may end in success or unsuccess, failure. Therefore, dichotomy. Therefore, whenever your left side is dichotomy, of course, the right side may be, as usual, several independent variables. Even you can include some categorical variables also, nothing wrong. But the left side, regarding left side, you must have a dichotomy. Please remember dichotomy variable. Therefore, for that, we are giving 0, 1, 0, 1. And here, when we go for interpretation, normally you can put 0 for anyone and 1 for anyone. Suppose success, if you take success, or failure, that is non-success, failure, or you can simply take the same word, we can use it, non-success, then dichotomy. You can give 0 for success and 1 for non-success, or 1 for, therefore anyway you can give. But which one you want to compare based, what is your base? What is your baseline? Actually, this is, people are using the word baseline data. That means when you compare, you have to compare only from a compare with the base. Therefore, if you want to make use of success as your base, then you could take 0 for that. And if you take non-success is your base, then you give 0 for non-success and 1 for success. Therefore, normally the base, what you want to have it as a base. Right. For example, if you take a disease, two possibilities are there, either affected by the disease or not affected by the disease. And this not affected by the thing, you can take 0. So that how much people can be affected, that you can find, and this you can take 1. Therefore, the first point we have to remember is it is similar to multiple regression analysis, but the left-hand side is a quantitative, for multiple regression analysis, it is a quantitative variable. But with respect to logistic regression, it is a dichotomic variable. And one variable we take it as 0, and another variable we can take it as 1. We can take it as 1. Suppose if you have not given 0, 1, if you are not given 0, 1, even if you give 1, 2, nothing wrong, then it will ask what is the first value that you have to give when you go for SPSS. Therefore, you read some material. Therefore, this is the first point. The second point is here you are predicting. Now you are going, when you go for prediction, you are predicting the quantitative variable. Here you are finding the variable, quantitative variable prediction in multiple regression analysis. But here you are not predicting. You are finding the chance of likelihood of being the category. And if you take this 0, 1, this is called indicator variable. You can see, therefore, the left side is normally we take it as indicator variable. Indicator variable means 2 groups, 0 group, 1 group. 0 group, 1 group. Normally, as a researcher, what is your baseline? For baseline, we are taking 0. And for comparison area, we are taking 1. Then, when you do, you are having, therefore, your answer, how the answer will be. If you do your multiple regression analysis, you will get a value, can take a value, any value in an interval, Therefore, it is a value. But here, it is a discrete value. It can take any means. Suppose it can take, suppose it is 3 to 5, any interval. Suppose the mark, suppose if we predict a mark of a student community, then marks varies from 0 to 100. Therefore, if you predict mark for a student with respect to some independent variables, then it can take any value in an interval, that is between 0 and 100. It may be any value. But here, it will take only one value. That means that value is in terms of probability. Therefore, what is the probability that he belongs to that group? That is the output thing. Now, when you go for graph, if you draw a graph, then for linear, it is become a straight line. But here it is S-shaped curve. Now, this you can find out. It is not a new thing. You can make use of this type of graph even for pattern. Now, all of you, we are travel in train. Suppose how the train moves. Suppose if you want to study the pattern of speed, the variation of speed, in what pattern? Please remember. Suppose variation of speed of a train. From a platform. Now, this I want to study. What is the pattern? Now you can see, suppose if you take the pattern, now the train is standing in the platform. Right. Now, the God-given whistle. Now, see the velocity. Now, this is speed or velocity. This is speed. Sorry. This is time. For example, time in seconds. And this is speed or speed. Now you can see this is in the platform now. God blow the whistle. Now the train start moving. First, you can see how it moves. First, it will go slow. From here, it will go slow, increase speed, slow, then slowly pick up. Then after that, it will maintain a speed. You see the curve. From the platform, it will go 5 kilometers speed, then it will increase to 10, 15, etc. Then once it left the platform, then it will go on and increase the speed. After that, it will maintain a speed, maintain that speed. It will maintain that speed. Now, this type of curve you can see, this is nothing but logistic curve. It's nothing but logistic curve, right? Therefore, logistic curve is a shaped curve. And here we are, if you want to go for this logistic regression, first of all, you must familiar with the three concepts, that is probability. One concept. Therefore, the probability of rain is 20%. Suppose probability for rain is 20%, means that there's a 20% chance. That is, in logistic regression, we are talking not estimating value, we are talking the chance. We are talking in terms of the probability of closeness to the other category, probability of closeness to other category. Then another one, the measure they are using is odds. Odds is given by a formula. It is a ratio. First of all, it is a ratio. As you know, if you say ratio, that means you are if you say ratio, that means you are having NR, that is numerator, and also a denominator. Numerator and denominator. And here the probability is taken on the numerator, and the 1 minus probability is taken on the denominator. And this value is called odds. Therefore, everything we talk in terms of probability. Therefore, we are calculating probability, then we finding odds probability. Then actually it is the working principle. Don't worry, because SPSS will give you all the results. Therefore, you must know simply how to interpret. Another one is logic. This is mathematics, mathematical part when you go for theory. Actually, this from P, you have to find out one factor which is called logic. You have to find out logic, because all our results are based on these three. Now we will go for some output. You can see the output. Then this is type of variables for linear regression, type of independent numeric, logistic regression dichotomy. Now the curve is straight line, the linear regression, but when you go for logistic, it is S-shaped curve. Then the purpose, what is the impact, how it changes. Here, what is the probability? We are talking in terms of probability. Therefore, all these things are there. You can please go through. Right. Now, these are all, if you go for SPSS output, now this is the first omnibus test model coefficient. And here, first of all, the model, before going for this model, then your model must be accepted. Therefore, model is valid. Here, this model must be rejected. Then here, another two factors, R square and Nagelkare R square, Cox-Net. This will tell you how much information it is given below. It is from net, I have cut and paste. It will tell you what is the purpose, how much amount of variation is explained by the independent variable on the dependent variable. Now the explanation of independent variable must be more, that is close to 1, says that model is excellent. The model is excellent. Therefore, your R squared is at least 0.6, or then the model is good. Model is good. The table. Now, this table is a very, very important table. And this table is called classification table. Therefore, here, how much percentage is correctly classified. And that is given by the percentage in the down. It is not due to me. Therefore, here the data says that when you say no variables, it is 73.5. But when you include the full model, that is variables include, it is 79.5. It is enough if it is cross 0.75. Then this is also, say, the model, you can accept the model. Therefore, R square, then classification, correct classification, all this help you to accept the model. Therefore, the model is accepted. Now we go for the finding the beta coefficient. You see the equation. See the equation. Now the equation is similar. See the right hand side of multiple regression is same as left hand side. You can see the same pattern, not much difference. There I have made use of alpha, beta 1, beta 2, etc. But the left side, not y. Please remember, not y. Instead of that, it is log of b by 1 minus b. Now this is the thing you have to carefully look into. This is called logit. This is called logit. Therefore, your answer is in terms of this logit. But this can be put it in a form. When you remove that, then you are having this column. Please see. Therefore, this exp column is therefore the two columns we are more interested. One is this one. This one helps us to write down the equation. Write down the equation. You see the equation. You can see now. This is the logistic regression equation. Logistic regression equation. You see the constant is 0.95. It's here, and each one 0.098 read, 0.066 sines plus 0.058 seconds. All these things, as we do in multiple regression analysis, here also we are using. This is our logistic regression model. But the question is, what is the contribution? Or what is the impact, or what is the contribution? And here, for that, not to answer that, you must go for the exponential of p. This is e to the power of p. Actually, this is in mathematics, this is e to the power of p. E to the power of p. That is what given there. Therefore, that is very important for interpretation point of view. When you see the theory, you will understand. Therefore, these are some of the things I want to tell you. Therefore, logistic regression is also a kind of regression where the left-hand side is a dichotomy. The left-hand side is a dichotomy. And in practical situation, whenever we want to compare with a base, that is, compare one category with other category, and we take one category as the baseline category and another one as the study category. And for the baseline category, we put 0, and for the study category 1. Then if you take an observation, then what is the probability of being in 0 category or 1 category? Therefore, that is given there. Now, the right hand side, what is the contribution? What is the contribution that is given from, it is exponential of b, it is e to the power of b. From that value, you can give the contribution or impact of independent variable on the logit, impact of independent variable on the logit. Therefore, there is no much difference. Therefore, these are the things actually I want to cover. Therefore, once again, before winding up, we will go for before winding up, you can see the slide. Actually, I asked Madam to put it on WhatsApp. That is the precisely what I am going to do in this talk is given in a flow chart. You can see, you might have had it in hard copy, or you might have it in this copy. Therefore, that will tell you that is correlation. You can see that thing. Another 5 minutes, we will summarize. Therefore, the correlation is used to find out the influence. The influence means the power to affect, whether X has the power to affect Y. If you want to answer that question, then you must go for correlation. And the correlation you are finding actually linear relationship only, nothing else. Whether linear is present or not, that is the point you are finding. And if it is present, then what type of relationship, then what is the strength of relationship. That another important point is X and Y are interchangeable. And in order to make interpretation according to the measurement scale, either you can make use of Pearson's coefficient correlation, or you can make use of Spearman's rank correlation coefficient, or you can make use of chi-square test for independence of attribute, as the case may be. When you come for regression, is useful for two circumstances. One is for a given data, you are finding the mathematical pattern. Suppose you want to find, because you can make prediction. Therefore, the prediction case, you have to go for a mathematical model, mathematical relationship, that is mathematical model. You have to find out. And here, your correlation is, interpretation is based on a single value you're finding or based on you're giving. But when you come for mathematical modeling, you are constructing an equation. And the coefficient of the independent variables will give you the impact of each variable on the dependent variable. That is what our main interpretation. But before using the model, the validity of the model, you have to check it. If the model is okay, then the model is accepted. Based on that, either you can do prediction or you can do which factor contributes, which independent variable contribute more towards the dependent variable y. And in this case, if you take only one independent variable and one dependent variable and the parameter is linear, then it is called simple linear model. Simple means not simple. That doesn't mean simple means simple means one independent variable. That is the meaning here. Therefore, simple linear model means one independent variable, whereas multiple linear model means more than one independent variable and a dependent variable. All of them are either in particularly the left hand side is always a continuous variable. In this case, the right hands may be, you may have some categorical variables. If you are having some categorical variables, you have to go for dummy. You have to introduce dummy variables and you have to perform the regression analysis. But if everything is quantitative variable, then you can go for multiple regression analysis and you can fit validity of the model. Before going for multiple regression analysis, all the assumptions must be validated, and finally you must go for the R-square value and also the ANOVA. You are having an ANOVA table. Don't confuse with our ANOVA with this ANOVA. This ANOVA is only for testing whether the independent variables are contributing towards a y. Therefore, that ANOVA table, you must get the result of rejecting. If it is all these things are fine, then your model is fit to the given data and you can go for prediction or interpretation purpose. But in the case when left side is a dichotomy variable, but the right sides are independent or categorical, no problem. Independent variables are scale or categorical. It is not a problem. If the left hand is happen to be a dichotomy, please remember dichotomy variable, then you must go for logistic regression analysis. The purpose is different. The logistic regression analysis, actually, if you take an individual, what is the chance of individual being in the first category, 0 category or 1 category? Therefore, in logistic regression, we talk about in terms of probability, not in terms of value. In terms of probability, based on probability, we are having logit and etc. Those theories, unless you read the theory, you may not get good understanding. Anyhow, this is a tool available if your left side is happen to be a dichotomy. Therefore, these are the thing I want to share in this session. Thank you very much for your patient listening.
Pravina madam.
Hello, madam.
Pravina madam irukanga illaya?
Susila madam.
Yes madam.
Yes, same madam.
Okay, any questions from participants? Any questions, any clarification to discuss with our resource person, please put it in the chat box. JP sir, edavadhu chat box la iruka?
Illa madam.
No, madam.
Shall I proceed to vote of thanks, madam?
Yes, madam.
Thank you, sir. Thank you. Ladies and gentlemen, very good afternoon to everyone present here for the IQAC enabled 2-week online international workshop entitled Research Methodology and Statistical Appliances SPSS for Social Sciences. Today, 29th July 2021, the session was handled by Dr. J. Stephen Vincent, sir, former head St. Joseph Department of Statistics, St. Joseph College, Trichy, and he has explained about the correlation, regression, and the logistic regression analysis with the examples, theory, and applications in research. So research is a diligent inquiry and careful research, search for a new knowledge. So he has explained the 7 stages in the research process. That is very, very useful for our upcoming research scholars and academicians also, sir. So just I wanted to highlight the points, reminding points. That is, there are 7 stages are there. Identify the broad area, select or fix the topic, research questions or write objectives, then formulate hypothesis. Then 4th one is research design and planning. 5th one is collection of data. Then 6th one is data analysis and interpretation. The last one is present findings. So he explained with the examples also. So nowadays we are in a pandemic situation. So sir has given the same example. That is stage 1 is a health care. Then stage 2 is a study about corona diseases. Then research questions also he has given with the examples are very useful and very understanding, easy to understand our research scholar. That is question 1, what is the growth pattern of corona disease? Question number 2, how many new cases will be after 2 days? What about the reactions after 2 days? Then the 3rd one is, does Covaxin is control the corona disease? Then 4th one is, between Covaxin and Covishield, which one is efficient? So he has given the cause and the effective, that is independent variable and dependent variable also. So does the smoking due to cause the lung cancer, then does nursing care cause rapid recovery, and does drugs that is cause improvement? So the smoking, nursing care, drug or the cause and the effect is lung cancer and rapid recovery and improvement. These are all the effects. So first we have to understand which is cause, which is effect. That is, the cause is the independent variable and dependent variable is the effect. So easily we have to understand, sir, by demonstrating with the illustration, sir. So then sir given explaining selection of statistical tools depends on. So that is the very, very important to select a tool. Then only we have to get the real output. The purpose of identify the variables involved, types of these variables and number of variables considered at a time. Then SAR has given the toolbox also, summarizing data or descriptive data, univariate, summarizing data and bivariate, constructing methods, that is mathematical and stochastic, then testing of hypothesis, that is a parametric and non-parametric, and applied statistics, that is time series, index number, vital stat, and psychometrics, etc. The analysis of variance and design experiments. Then he has showed the advanced tools also. Then data analysis based on the number of variables, that is univariate data analysis, that is considering only one variable, bivariate data analysis, 2 variable at a time, then multivariate data analysis, more than 2 variable at a time. That we have to note, scholars, please. Then part 2, he is moved to the part 2, that is a correlation analysis. The purpose of correlation analysis is to find the existence of a linear relationship between the variables. However, the method of calculating correlation coefficient depends on the types of measurement scale, namely the ratio scale, ordinal scale, and the nominal scale. So measures of correlation is given the graphical method, that is cat diagram, numerical approach, and Pearson's product moment coefficient, and Spearman's rank correlation also. Then he has given the reliability to utilize the correlating coefficient. Then he has given the attribute that is not measurable, that is non-measurable, X qualitative categorical, and Y is a qualitative category demonstrated, and the spot he has explained very nicer. Then he has explained the chi-square test, that is independence of attribute also. Then move to the 3rd part, that is regression analysis. The correlation coefficient is a useful statistical tool for describing the type, that is positive or negative or uncorrelated, and intensify of relationships such as moderately or highly between the 2 variables, but it fails to give a mathematical functional relationship for prediction purpose. SAR is given and the examples, a cause and effect diagram, 1 variable or more than 1 variable, mathematical equation. That also he has demonstrated by using the example usage of cell phone and all. Then he moved to the part 4, logistic regression. That is, he has explained in terms of probability he has given. So linear regression versus logistic regression, mathematics of logistic regression, model summary, everything, sir. He has explained in an easy manner. Definitely it will be useful for our researchers as well as academicians. So thank you so much, sir, on behalf of the organizing committee, Department of Education, Anova University, for sparing your precious time. And I hope your presentation and demonstration, everything was the most motivating, interesting, and that it will be benefit to all our participants, especially our research scholars, academicians. I thank all the participants staying with us throughout the session. Thank you very much. Thank you once again, sir. Thank you.
Thank you.
Thank you, sir. Thank you, sir. Participants, we can join for the afternoon session at 2:50 p.m. Thank you all. Susla madam, thank you, madam.
Thank you, madam. Thank you, madam. Sir has explained in an easy manner, madam. Today's
Yes,
session
ma'am.
is so interesting. Thank you, madam.
Thank you, madam.